Here we're going to take another look at this ternary system that involves forsterite, anorthite, and a silica-rich polymorph, or a pure silica polymorph. And we're going to look at this composition here, this white circle, and we've had this line waiting in the wings to help guide us as to what's going to happen with that bulk composition. Let's say the bulk composition starts as a liquid. Well, that liquid falls within this field here of forsterite plus liquid. Here we care about this cotectic here, this peritectic curve there, and then the boundaries of the triangle. And so that means since it falls in the forsterite plus liquid field, it'll crystallize forsterite plus liquid first. But take a look at that white dot relative to this dashed line. It falls to the right of the dashed line. So the final rock is going to consist of anorthite, enstatite, and a silica-rich polymorph. There will be no olivine, no forsteritic olivine to be found when the rock is done crystallizing. So what will happen there? Well, we'll draw a line. Let's see if we can get this to work. We want it to emanate from that forsterite apex, and that will be the guide. That will guide us to where that liquid will travel. So we have a liquid that starts here at the white circle. It's going to move away from forsterite towards this peritectic curve here. The liquid, when it reaches this point, will begin precipitating enstatite, and as it does so, the silica-rich liquid will begin reacting with the forsterite and consuming it. Now, when will the forsterite be completely consumed? Well, the liquid will travel down this peritectic curve where it will eventually reach 1270 degrees centigrade, and that is the point at which forsterite will no longer be present. The liquid will sit there at a constant temperature of 1270 degrees, reacting until there's no forsterite left. And when there is no forsterite left, that frees the liquid to now go down temperature below 1270 and move along this segment of the curve over here. Now take a look at this segment of the curve. This cotectic here is between anorthite and enstatite. So the only way that this curve can sit on this cotectic, which equilibrates anorthite and enstatite, is if the forsterite is gone. So as long as we're following this curve, then we're on the forsterite plus enstatite boundary, so forsterite must be present. Once we hit that point, forsterite, anorthite, and enstatite precipitate together, but if there's enough liquid left so that we can completely react out the forsterite, then we can start moving down this curve and heading towards something that is quartz saturated. So when we migrate down this curve, eventually at 1220, we're going to hit this eutectic here. It's a eutectic between anorthite, enstatite, and cristobalite, or actually rather tridymite, because we're at a lower temperature here. And those three minerals will precipitate out together until the liquid is completely gone. So this is the composition of the last liquid at this point D. That temperature will remain constant at 1220 degrees centigrade as the system precipitates out all three minerals. And then when we are done, we will have a rock that will be made of, and this is a little bit tricky, it'll be anorthite plus tridymite in this case, and enstatite. Even though it started out here in the forsterite plus liquid field, there's not going to be any forsterite left. That'll be completely consumed at 1270. There will be no more forsterite as it gets down to temperatures of 1270 or below. So we don't, when it's solid, we don't really care about this forsterite plus liquid part. All we care when it's solid is about that dashed line and which side of the line it's on. And since it's on the quartz-rich side or the silica-rich side, there will be no forsterite left. It will start out making forsterite, but it won't have any forsterite left when it's done.